Hello. Now we are going to look at conversion graphs. And a conversion graph means to convert is to change from one thing to another, and a graph is a name for a particular type of picture. So a conversion graph is a picture that shows the relationship between two things, how we would convert, how we would change between two things. We're going to start off with an example that we should have a fairly strong intuition for already. And that's this graph here. This conversion graph gives me the relationship between centimeters versus millimeters. So if I take out my ruler, I know what this relationship is. There should be 10 millimeters for every 1 centimeter. If I look at my ruler, the little gaps that are about the size of my little finger on my ruler are my centimeters, and there are 10 little dashes in between each one of those bigger dashes, and there are millimeters. So we know what this relationship should be. So we're going to use this example of where we're already confident with what the relationship should be and see if we can look at what this looks like in a conversion graph type setting where we have a picture of this relationship drawn. So anytime we draw any graph, we always need to have our axes labeled. So we're counting our centimeters going across here. So we have 1 centimeter, 2 centimeter, 3 centimeter, and here we are going up in millimeters. And I have millimeters written here, centimeters written here. So I've clearly labeled the title and what each axis means, what each one of my measurements means in both the up and down and the side to side direction. So that's really important for our long-term work with graphs, with these types of pictures. Now, let's get into the question. We are asked to use the graph to find 1 centimeter in millimeters. Well, I know what the answer should be. It should be 10. But how would I look at this on my graph? Well, I'm told about centimeters. So I'm going to go to my centimeters line and I'm going to find 1. So there's 1 on my centimeter line. This diagonal line here is what gives me the relationship between these two things. And the way I read it is I go up to my diagonal line, the relationship line, and then I go across to my millimeters axis. And that allows me to see that 1 centimeter is to 10 millimeters. So that's how I can read that information off the graph. I already knew that as a fact, but I can see that now in my relationship. I go from the information I'm given, the 1 centimeter, up to my relationship line, and then I go across to read my millimeters. Now this is also a coordinate. If we think about this, if we know our coordinates, this would be either coordinate 1, 10, where our centimeters are the 1 and our millimeters are the 10, the up and down axis. But for right now, we're just going to read this off of our graph, and we can think about our coordinates too. Now, let's go on to our next question. What is 3 centimeters in millimeters? I go to what I'm told, and then I want to find what that is in millimeters. So I want to know how high up that should go. So I go trace my line all the way up to my relationship line, and I go all the way across as neatly as I can to my 30 millimeters. So 3 centimeters is to 30 millimeters. Now, here's one that's a little bit different now. What is 15 millimeters in centimeters? So now I'm given millimeters. Before I was given centimeters. This time I'm given millimeters. I'm going to change color for this one. No huge significance to it. It's just so the diagram doesn't get, or the graph doesn't get too cluttered. I'm told about 15 millimeters. So I go to the millimeter axis. The millimeter measurement is 15. And now I want to go across to my relationship line and then go down as neatly as I can. I want to go straight down. Don't actually have a nice line to follow here. So I need to look carefully here. I ended up in the middle of this box. So there are 1, 2, 3, 4, 5 little boxes in between each of my numbers. And I've gone 2.5 boxes across. So I've gone halfway across. So that would be 1 0.5, 1.5 centimeters. So 15 millimeters is to 1.5 centimeters. So you could write that as 1.5 or 1.5. You'd be perfectly fine writing it either way. Now, what's 20 millimeters in centimeters? Basically the same thing. We start off here and we say, what information am I given? I'm going to go to there on my diagram. So I have 20 millimeters, and then I'm going to go across to my relationship line, and this time it's nice. I'm going to a solid line, and I go down to find what the equivalent centimeter is. So that's going to be 2 centimeters. 20 millimeters is to 2 centimeters. Now, based on the graph, so based on the relationship line that we're given, what is 10 centimeters in millimeters? I can see my centimeters only goes up to 3 on my graph, but I'm given to believe that this relationship keeps going. So can I use this relationship that I've figured out to find out what my 10 centimeters would be in millimeters? Well, from working with the graph, I know that 3 centimeters is 30 millimeters, or if I simplified it to the first thing I was asked, 1 centimeter is 10 millimeters. So if I know from my work with the graph that I can simplify my ratio to 1 centimeter is 10 millimeters. I got this from my graph, and now I say, well, I want to know what 10 centimeters is. So I multiply, beg your pardon, I multiply both sides by 10. So if I make my centimeters 10 times bigger, I'll have 10 centimeters, and then I need to make my millimeters 10 times bigger as well. So I end up with 100 millimeters. So we can use the relationship that we've got from the graph and extend it beyond where the graph is drawn. Now in science, we would need to be very careful that we only did that if we had a reason to believe that the relationship kept going beyond where we had graphed. So this is not something you would always do in the sciences, but in this case we can see that this relationship should keep working. Our ruler isn't going to change its shape as we get bigger, so it's reasonable for us to keep going beyond where we have graphed. But we do need to be aware of it as a fact. We wouldn't do this without thinking carefully about it, that we're not going to try and use a relationship that doesn't work outside of a particular boundary. But for maths, for now, this is perfectly fine. Now, let's take another example. A plant starts out 3 centimeters tall and grows 2 centimeters a day. From the graph, how tall is it after 1 day? Well, let's go to our graph. You can see here we have our title and we have each of our axes labeled. So I'm counting up the days along the bottom axis, along the x-axis, and I'm counting up the height of the plant along the y-axis, the up and down axis. So how tall is it after 1 day? Well, the information I'm given is about days, so I'm going to go down to the days axis, and then I'm going to go up to my relationship line, and then I'm going to go across, and I can see that it should be 5 centimeters after 1 day. Now, this story here would actually allow us to figure out what the height was at different days, but we're focusing on our picture, our graph for right now. So in 1 day, it would end up being 5 centimeters tall. That looks a little bit like a 6. So in 1 day, it would be 5 centimeters tall. And we get that from our graph starting at 1 day, because that's what we were told about, go up to our relationship line and across to our height. How many days until it is 9 centimeters tall? I'm going to change color again. There's no particular significance to why, just to have some variety. So I have 9 centimeters. I'm told about a height, so I'm going to go to 9 on my axis, my height axis, because that is what I'm told about. And then I'm going to go across to my relationship line, straight across and straight down as neatly as I can. And that's going to tell me that that's going to take 3 days. So it's going to take 3 days for my plant to get 9 centimeters tall. So it's going to take 3 days for my plant to get 9 centimeters tall. Now, two things I just want to remind very quickly. Again, this is effectively talking about coordinates. This would be the coordinate 3 on the days, 9 on the height. This would be the coordinate 1 on the day, 5 on the height. Just linking it into what we know about coordinates, this relationship between our x's and our y's. The other thing to point out is, do we have something that is directly proportional here? And we don't. So when we had our centimeters and our millimeters, if we made the centimeters 3 times bigger, if we went from 1 centimeter to 3 centimeters, we made it 3 times bigger, we made our millimeters 3 times bigger. But here we have 1 day is 5 centimeters and 3 days is 9 centimeters. That isn't 3 times bigger. So this relationship here is not directly proportional because the ratio doesn't stay the same all the time. So this is directly proportional. I'm going to write that down for you. So for directionally proportional, the ratio stays the same, and we can see that that's true here. It's not true here. I made the days 3 times bigger. I didn't make the height 3 times bigger. Now, finally, how many days until the plant is 6 centimeters tall? Well, we're told about a height. So we're told about a height. So we go to 6 centimeters. And then we're going to go across to our relationship line and down as carefully and as neatly as we are able. And here we have 1.5 days. We've gone 1.5. We're halfway to 2, so 1.5 days. So 6 centimeters, my apologies. 6 centimeters is to 1.5 days. And the order in which you write those doesn't matter so long as you're careful with your units. Leading into what just final point, based on what we were just talking about here, where we're able to extend our rule out to 10 centimeters. So we only had the graph drawn for up to 3 centimeters, but we're able to use our rule out to 10 centimeters. It should be fairly obvious that as the plant gets bigger and bigger and bigger, it can't keep growing at 2 centimeters a day, because after 10 years it would be way up in the sky. So this relationship isn't going to work forever. So this is what I'm talking about, that we need to be careful in a physical situation that we aren't going to use our relationship outside of where it makes sense. This relationship is working for where the plant is very young, when it's very small, and it's growing consistently at 2 centimeters a day. But as it gets much bigger, that might not be true anymore. So we have to be careful about these relationships when we think about the physical meaning of them. If we're dealing with a physical situation, that these relationships could change as the days get bigger and bigger and bigger. The height isn't going to get infinitely big. Now, that is what we need for our conversion graphs for now.